Hello everybody, I'm David Sanchez Hernandez, CEO of EMITE, and we're having here quite an exciting measurement with the brand new CMWflexx from Rodinsworth. Here the eNote B that is able to measure 3 downlink carrier components for LTE plus MIMO and everything over the air with a reverberation chamber from EMITE, the E500. So we're going to show how easy you can measure that cutting edge figures of merit with this outstanding combination. We have here the E500 reverberation chamber. You can see that it's loaded with the absorbers and it's empty of electronics. You can see the steers and the basic configuration of the system. Connected to this reverberation chamber, we have a brand new CMWflexx from Rodinsworth, which is composed of mainly 3 basic components, 2 different CMW500 units. We have one that is pre-configured, have 2 carriers with MIMO, and a secondary one which is able to drive the 3rd carrier component. And everything is controlled by a CMWC, the controller from Rodinsworth, which acts as a control PC that is remotely controlled by the EMITE graphic user interface software. So things are quite easily to be handled in this combination. We have to go to the software by EMITE and then select the active MIMO OTA measurements, and simply load a setup file that we've saved before for measuring throughput for this LTE carrier aggregation combination. We're going to test band 1 plus band 3 plus band 5, and once the setting is loaded, we can check on the properties of the test simply by selecting the correct pane. So we're going to have 3 components here: primary, secondary 1 and secondary 2. Those are configured by the system. We're going to measure throughput. For the power control, there's a possibility to change or alter the physical channel parameters according to different standards. We're going to follow the CTIA one in this demo. The connection to tap shows that we're going to measure open loop spatial multiplexing, that's 64 QAM, so that it's a downlink MCS of about 20, and we will run throughput from -85 all the way down to -120 dBns per 15 kilohertz. So that's RS-EPRE. Searching at the same time for the sensitivity of the measurement, which is set to be at 70% of the maximum throughput. And this is it. Basically, we just have to press next. A summary of the measurement starts, and then we press run, and the system software starts configuring the CMWflexx for the measurement. So we have installed, it's not required, but we have installed a screen to be able to observe the changes on the CMWflexx system. The first thing that the system does is to reconfigure the cell for the carrier aggregation combination for the network, and also configure the reverberation chamber for the measurement that we have in hand. That takes some time. Signaling is being turned on the system. You can already see on the screen of the CMWflexx that there is up to 4 carrier components, and that's only limited by the capabilities of the handset, smartphone or tablet that we're going to test. So this is it. If you can see here basically in the screen that the cell is on and there's nothing connected yet to the system. So the next step is to ensure that the connections are correct as the software shows, the RF connections that is. and then run the attachment mode. It's very simply done in the EMITE systems. We have one of the latest cutting-edge carrier aggregation phones in the market. We just put it inside the chamber like that, and we can see in the screen that it's already attached. Close the door, and perhaps it's possible to see this in low speed, but basically it's very easily attached. And if we select the secondary carrier, we can see that it's band 3. Everything is set to QPSK for attachment, and then will be changed for the measurement. And then secondary component number 2 is band 5. So we have a combination here of 3 components, and all 3 components are status is identified here in the main screen as attached and connected. It's also interesting to see that it is possible to see the capabilities of the device here. For example, you can see, the band combinations that this device supports. Quite many of these combinations, and some other things for the device. For example, the handover, for the device that can go into TDD 128, this high unlicensed frequency band, GSM, CDMA 2000, or other FDD bands. Good. So this is the main screen. We'll try to run the measurement now. It will simply press run here on the software, and we'll try to show the screen, the main screen of the CMWflexx. As you can see, the software connects or checks that the connection of the device is correct, and it will very soon start the measurement. Connection has been established, and there you go. Right, there's a choice to have some warming up period for the device so as to have the same setting conditions for the test, and then you can check the measurements in text format like this one, or display format here. We're gonna see for this first partial measurement that there are gonna be 3 curves being measured: primary throughput, secondary throughput, and overall. And all those 3 curves will progress for each partial measurement, and then as partial measurements are collected, results are added and averaged to get the final values. And this will be done for some time, and you can follow the progress, as I said, either in text format and even remotely from your desktop somewhere, or in display format. At the same time, while the measurement is being performed, you can check the properties of your measurement. So therefore you can verify that the measurement is set as the same way you wanted it to be. Check the bands, the settings for each band, and the throughput settings, and some other things here. You can even have pass and fail criteria to automatically set the report that we will see when the test is finished. You can also show a summary of your test. Say the software is able to handle handover and call drops automatically, so this can run overnight. So if you have to set 20 different tests, it's good to have a summary of how your test batch is evolving, and obviously, as I said, in the display mode. Right here in the display mode, although until you get quite a large number of samples, it's not accurate enough. You already can see 4 curves in this display, 4 permanent curves, and then 4 instantaneous measurements. 3 instantaneous measurements. So that you have, when this partial measurement is finished and added to the ones we have already, we will see clearly that you have primary, secondary first, and secondary second. And Here you go. So you have the gray is the one behaving in the worst behavior, then the dark blue and the light blue, and all those three which have a maximum throughput of about 35 megabits per second add up to get the overall curve, which is the dark green, and that has a maximum of about 106 megabits per second. All right, so this is it. We're just performing 3 downlink car components plus MIMO over-the-air measurements with this outstanding combination. The interesting thing about this is that it's very useful to rank devices, so that you have a very clear, once the test is finished, you have a very clear view on how the device performs for that combination of bands, and then you can compare sensitivity values for each particular component, primary, secondary 1 or secondary 2, or even the overall, to that sensitivity of a different device, and then rank the devices in terms of their performance over the air for the MIMO modes. Alright, this is going to run for some time now. Roughly, a simple test will take between 5 to 7 minutes. We've just done about a quarter of the test, and so that we will let it run for some time and then get back to the report when the test is finished. Well, this is about to finish now. We can see here clearly that light blue, the secondary 1, performs better than dark blue, which is primary, and then gray color, it's the secondary 2 that is the worst one. And then you have here the overall performance in a slow decay, which is expected from maximum throughput down to 0. I think this is the last partial measurement, so we're about to finish, then we will be able to see how the report is structured. Done. Okay, we have the possibility to name the file, the model or brand, even the measurement. I'll save it as general name here, and then we can just open the report. You can see here that you have a summary of your device and your connected equipment here. This is also observed here in the software. You have the E500 reverberation chamber plus Ruddernsworth CMWflexx shown here, and then you have a summary of your measurement with the MTS, the MIMO throughput sensitivity value that's been measured for that device, and then a detailed list of the values measured for all the components, primary, secondary 1, secondary 2, and overall for the different power values, as well as the graph that you have here. And this report is also saved in text format so that you can import and export to your own software processing tools if you want to do that. So this is it, very simple MIMO OTA measurements for 3 downlink car components in LTE with a brand new CMWflexx and EMITE E500 reverberation chamber. Thank you very much. Once more, cutting edge in the MIMO OTA testing arena.